In this video, we're going to talk about solving rational equations. So up until this point, we have practiced multiplying, adding, subtracting, dividing. Now we're going to solve. So your answer when you say, when you solve should be x equals a number, okay? So let's think about how we solve two fractions like this, two fractions on each side of the equal sign. And usually what we do here is we cross multiply. So cross multiply means I'm going to multiply x times 2, which I'm going to write as 2x. That means they're being multiplied. And then 3, I'm going to multiply to everything on the other side of the equal sign. So that means I'm multiplying 3 times x, giving me 3x, plus 3 times 2, which gives me 6. Okay, so then I'm going to go ahead and solve for x. That's what solve means. I would move the 3x over first. That gives me a negative x, and then a 6 on this side. So to eliminate that negative, I can either divide out by -1, or you can multiply by -1 to both sides. You have an option there. And then you get -6. Now, I want to make sure that I'm going to check my answer for these. So my check here would be to replace x into the original equation and see if it works out. So if I were to substitute in the x there, I would have -6 divided by 3 equals -6 plus 2 over 2. -6 divided by 3 is a -2. -6 plus 2 is -4. -4 divided by 2 is a -2. So this works out. Okay, so this is the process we're going to follow for solving rational equations. So this looks similar, hopefully, to what we did last time, the adding and subtracting. And remember, in order to add or subtract, we have to first make sure that we have the same denominator. So looking here, I have x plus 2. In this one, I have x minus 2. And this one right here would factor out 2x plus 2x minus 2. Okay, here's the new part. We have an equal sign. But for now, I'm going to focus on making sure that they all have the same denominator. So think about what each part is missing, okay? On this side, we have an x plus 2, like we stated at the beginning, which means this is missing an x minus 2. So I'm going to multiply both the numerator and denominator by x minus 2. On this side, this says x minus 2 already, so it's missing the x plus 2. So I'm going to be multiplying the numerator and denominator by an x plus 2. That middle one with the 8 doesn't need to be multiplied by anything, so I'm going to just leave it. Now, once I have, and here is, I'm going to write the additional step here. Once I have a common denominator, and this step that I'm writing right now, you will be able to skip once you're used to these. So I'm writing out everything all over again. X plus 2, x minus 2 equals now 2 times x plus 2 over x minus 2, x plus 2. So what happens here when I'm solving, and this is when you're solving only, once you have the same denominator, you can just ignore the denominator, okay? So once common denominator is found, we are going to ignore denominator and focus on numerator. Okay, so I'm going to go ahead and say, all right, goodbye, denominator. I don't care about you anymore. And I'm just going to write the numerator, and that's going to be the equation I will be focusing on. So all I'm writing right now is that numerator, okay? So then think about how you solve for x. Well, you would probably want to simplify any parentheses here. So I'm going to distribute this out. That gives me x squared minus 2x. That -8 I haven't done anything with. And then I'm going to simplify this one. I want to move everything to one side, so I'm going to subtract the 2x over. And I'm going to subtract the 4 over as well. That way the right side is just equal to 0. That gives me x squared minus 4x minus 12. So think about this turns into a quadratic. So you can factor this out. We're going to factor what two numbers multiply to negative 12, but add up to a negative 4. And so hopefully when you're factoring, you think it's negative 6 and positive 2. Okay, so if I were to set each factor equal to 0, I get x equals 6 and x equals a negative 2. Okay, so what I'm going to do here is I have to go back and check my answer. Anything, and here's a rule, anything that makes the denominator 0, and we're going to talk about these rules here in a second, are not going to work out. So looking at the denominator, there's two parts that would make the denominator 0. Looking here, if I were to set these equal to 0, I would get x equals 2 and x equals negative 2. So these would not be allowed. These answers would not be allowed because if I were to substitute in 2 here, that's going to give me a denominator of 0. If I were to substitute in negative 2 here, that would give me a denominator of 0. And I don't want a denominator of 0. That's one of the rules with rational functions, okay? So even though you get two answers here, x equals 6 and x equals negative 2, this one is what's called an extraneous solution. So we don't want it because it makes the denominator 0. Okay, we don't want that. So my only answer is x equals 6. So even though in the very first example, we checked that it was true in the equation, when you're dealing with rational functions, you want to check if the number will ever make the denominator 0. And if it does, you don't want it. Okay? So let's talk about how to solve these. Express rational equation with a common denominator. So we already did that. Remember, once you find the common denominator, you can ignore the denominator and just focus on the numbers on top. Okay, and then we just talked about what an extraneous solution is. So an extraneous solution is going to be anything that would make the denominator equal to 0, or an untrue statement. What I mean by untrue statement is if I were to go back to the very first example, if I were to substitute in anything else other than negative 6, this would not be a true statement, okay? So something like 12, if I were to substitute in 12, I would get 4 on one side and then 7 on the other side. So it would not be a true statement. That's what that means, okay? So let's go ahead and jump into some examples here. So solve each rational equation. In this one and in any other one, if you have multiple denominators, think about what you want to do. You have for this one 2 options, but I'm just going to kind of get you used to finding the common denominator. So looking at these denominators, this is 5x and this is x minus 7. So I'm going to multiply each side by the opposite denominator. So I'm multiplying this side by x minus 7 and this side by 5x. Okay, essentially what you're doing is you are cross multiplying here. That's what you're doing, but I'm writing it this way so that you get used to it once they get longer. Now that they have the same factors, both of them in the denominator, now I can just focus on the numerator. So my numerator now here is x minus 7 times 3. And here it's 2 times 5x. So I'm going to go through and simplify that by distributing it out. So I get 3x minus 21 on the left. And then 2 times 5x is going to be 10x. I'm going to subtract 3x from both sides. I'm starting to solve for x. That's what solve means. And I get 7x here. Then divide by 7, cancel, and then I get negative 3 equals x. Before you circle your answer and say, yep, this is it, this is my answer, check a few things. Does anything make the denominator equal to 0? If you were to go back to your original, okay, so I'm going to erase, actually, I'll just add it over here. So if I were to go to my denominator for the first one, does that equal 0? No, that equals negative 15. And then if I were to substitute it in this one over here, negative 3 minus 7 equals negative 10. So it does not equal it to 0. And it's also another check would be to substitute in the value and make sure that it gives you a true statement on both sides. So here we get 3 over negative 15, and here we get 2 over negative 10, which both of those reduce to 1 negative 5, 1 over negative 5. Okay, so they do check out. They are the same answer, so your answer is x equals negative 3. Okay. All right, moving on to the next one. So here, again, looking at those denominators, what is the other side missing? So this denominator is 2x plus 5, so I'm going to multiply this side by 2x plus 5, and that's in the numerator and denominator. And then this side is 11x plus 8, so I'm going to multiply this side by 11x plus 8. Okay, so now that I have the same values in the denominator, I can just focus on my numerator. So in my numerator, I have 11x plus 8 times 1 equals x times 2x plus 5. So again, I'm just focusing on the top now. Distribute out the 1 on this side, gives you 11x plus 8. Distribute out the x on this side, that gives you 2x squared plus 5x. Okay, so my goal here is to get everything on one side so I can start solving for this quadratic. I'm going to move it over to the right this time just because my x squared term is positive on this side, so I just want to move it that way. Leaving me with 2x squared minus 6x minus 8 as my quadratic. Okay, I'm going to factor this out. First, by taking out a greatest common factor here, they all have a 2 in common. So I'm going to factor out a 2. And that gives me x squared minus 3x minus 4. Then I can factor that out a little bit more. So two numbers that multiply to a negative 4 but add up to a negative 3. That would be x minus 4, x plus 1. So when I set each factor equal to 0, my answers are x equals positive 4 and x equals a negative 1. Now, go back and check that neither of these make the denominator 0 and that they work out for your fraction. So if I were to substitute in a 4 for my denominator for the first fraction, it's going to give me 13. And if I were to substitute in 4 for the second fraction, it's going to give me 52. So neither of those are 0. I'm good. Same thing with the negative 1. Kind of do some mental math there. Make sure that it's not a 0, and you are good. So in this case, both of these are going to work out. So both of those are my solution. Okay. All right, let's keep going. So here we have one that we did just like right at the beginning, where our denominators, this one's an x minus 3, this one's an x plus 3, but this one actually factors out to x plus 3, x minus 3. So then you just have to make sure that you are multiplying by whatever it's missing, right? So this is an x minus 3, and this one's an x plus 3 that it's missing. And now that you are multiplying the numerator and denominator by everything, they have the same denominator, so you can just focus on the top and write out your problem and start solving for x. So we have x plus 3 times 6 equals 8x squared minus 4x times x minus 3. And then go through, simplify, distribute, all that fun stuff. So here we go. Distribute this out. 6x plus 18. And then I'm going to distribute this out. So I'm not doing anything with the 8x squared. But then I'm multiplying minus 4x squared plus 12x. Combine like terms. So this turns into 4x squared. Okay. I can also start moving things around. So I'm going to subtract the 6x. And I'm also going to move the 18. Okay, so I'm just kind of saving some steps here. Plus 6x minus 18, we get there. Moving right along, I can factor out a 2 from everything. So this is where your factoring skills have to be good. 3x minus 9. Okay. Now, if you don't remember how to factor trinomials like this, please ask us for help. So essentially, what you're doing is you want to multiply these two together. So what two numbers multiply to give you a negative 18x squared, but add up to your middle term, 3x, okay? So hopefully you're thinking that is 6 and 3, 6 and 3, but one of them has to be negative. And so in this case, it's the 3 that needs to be negative in order for my sum to be positive. So you take these factors that you came up with and you replace this with it. So instead of 3x, I'm actually writing 6x minus 3x, and then bring down the negative 9, bring down the 2x squared. This is called factor by grouping. And again, if you are having trouble with that, let us know. We'll help you out. Then you focus on the first two, take out the greatest common factor there. That comes out to be a 2x, and that leaves me with x plus 3 on the inside. Focusing on this one over here, I have a negative 3 in common, leaving me with x plus 3 on the inside. So this factors out to 2x minus 3, whatever you took out, is one factor. And then whatever they have in common, the x plus 3 is another factor. When I set these equal to 0, I get x equals 3 over 2. And x equals negative 3. I just took each of these factors and set it equal to 0. And then I have to check, do either of these answers give me a 0 in my denominator? Okay, so this one looks like it might. If I were to substitute that into negative 3 over here, negative 3 plus 3 would be equal to 0. So I cannot have this one. It's an extraneous solution. This one would not make anything 0, so I can actually use it. And that is my only answer in this case. All right, just 2 more examples here. So in this one, we're looking at the denominators. I see that these have common denominators already. The only one that's missing a common denominator is the 7, right? So how do we get a common denominator? Remember, you're going to multiply the numerator and denominator by that. So when I do that, that means all of them have the same denominator at this point. So I can just focus on the top and solve my equation that way. So the 7 is now being multiplied by x minus 2. And then we have a plus 10 there. Okay, so distribute that out. We have 5x equals 7x minus 14 plus 10. Combine like terms. That gives me a negative 4. And I'm actually going to subtract the 7x over. That gives me a negative 2x equals negative 4. Okay. Divide both sides by negative 2. X equals a positive 2. So go back to the original equation. If you were to plug in 2 into this equation, does that equal 0? Yeah, it does, which means there is no solution. Okay, even if you only have one and it doesn't work, that's okay. You can say no solution. All right. So same idea. Go ahead and try our last one for today. Try this example right here. Pause the video now and come back to check your answer and see how you did. Okay, so last one here. Looks like this one's missing a common denominator. This one's going to factor out to an x plus 1, x minus 1. So this side is missing an x plus 1. And then this 5 is actually missing both. So we have to multiply this by an x plus 1, x minus 1. Okay, and then it's going to be the same thing in the denominator. So now that all my denominators are going to be looking the same, I can focus on just the numerator. So this, when I distribute it out, I get a 7x plus 7 minus this 5 is now going to be multiplied by an x plus 1, x minus 1, and the minus is going to come with it once I do that. And then this side is just going to equal 6, okay? So to make my life a little bit easier here, this is going to multiply out to x squared minus 1, just like the denominator. And then I'm going to distribute out that negative 5. So that leaves me with negative 5x squared and then plus 5 here. And I can bring this down, 7x plus 7 equals 6. So it's going to turn into a quadratic here. I'm going to combine like terms, and I get negative 5x squared plus 7x. Then I have plus 12 equals 6. I can subtract the 6x, or just the 6 over, and then I end up with the following quadratic. Okay, so from here I'm going to go ahead and factor it out, solve for my x's, and check which one's going to work. So again, it's not a equals 1, so we have to do a little bit more work. What two numbers multiply to a negative 30x squared but add up to a positive 7x? So it's going to be a combination of 10 and 3, but I want my sum to be a positive 7s, which means the negative is going to go for the 3x. So that means I'm going to split up my middle term. Instead of writing 7x, I'm going to write 10x minus 3x and then plus 6. Then I'm going to factor by grouping the first two numbers. I can take out a negative 5x, leaving me with x minus 2 on the inside. For the second one, I can take out a negative 3, leaving me with x minus 2 on the inside. So this factors out to negative 5x minus 3 and then x minus 2. When I set each factor equal to 0, I get x equals negative 3/5. And then set this one equal to 0, I get x equals positive 2. Go back and check, can either of these make my denominator 0? Okay. And then neither of them do, so then these are both solutions.